Tonight I'm going to talk to you about quadratic residue. Now, what is quadratic residue? Okay. Let's go back to modular arithmetic. Okay. Now this is sort of like when you had the clock. Okay. Now you have 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, but as you get over to the 12, when it finally becomes 12 o'clock, in modular arithmetic, it never becomes 13 o'clock, or 14 o'clock, or 15 o'clock. Okay? Once you hit that 12 o'clock, it starts at 1 again. Okay? So, let's say we have a set of 10 numbers here. 1, 2, 3, all the way to 10. Once you reach 10, it goes back to 1. So you count up again. And once you reach 10, it goes back to 1. And once you reach 10, it goes back to 1. Okay? So basically, you count up to 10, and then after you counted up to 10, you start counting from 1 again. Okay? And that's the same way with a clock. Now, I should mark this correctly, because this is not an O. This is actually a 0. Now, do you remember me telling you that 0 was actually the absence of value? Okay, so when we say that 0 is less than x and x is less than p, p is pretty much anything above 0. Okay, but x has to be a number above 0. Okay, so the p has to be greater than x, but the x definitely has to be a number above 0. As long as x is greater than 0, even if it's less than p, then x squared equals q mod p. Mod standing for modular arithmetic, p standing for the rotation. Okay, now this rotation could be 7. You can count up all the way to 7 and start over at 1 again. Or you can count to 13 and start all the way back at 1 again. But whatever your rotation is, in this case we're going to say 10. When you stop at 10, you start at 1 again. Alright, now, when we show 4 squared equals 6 mod 10, what we're going to say is we're going to count to 10. 1, 2, 3, 4, 5, all the way up to 10. And then we're going to start back at 1 again and count all the way up to 6, because 16, of course, is bigger than 10. So, we're going to say we'll count up to 10 and we have to count up to 6 again. Let me say that again. We're going to first count to 10, then we got to count to 6 again in order to reach this modular arithmetic. So 4 squared is 6 mod 10, because we've already counted 10 and we're going to count 6 more. This 6 right here is the quadratic residue. That's what it is. The 6 right here is the quadratic residue, just like the Q. The Q up here is the quadratic residue. Okay? So, if you have 5 squared, you're going to have 5 mod 10. Why? Because you're going to count to 10, you're going to count to 10 a second time, and then you're going to count 5 more to get it. Now what if you have 6 squared? Well, that's going to be 36. So, you're going to count to 10, count to 10, then you're going to count to 10 again, and then you're going to count to 6. So, 6 squared is going to be 6 mod 10, because you're counting to 10, 10 again, 10 again, and all the way up to 6. Okay, now you say, well, what about 7 squared? Well, 7 squared is 49. Alright, so you're going to have 9 mod 10. How do we know it's 9 mod 10? Because when we count 10, 20, 30, 40, then we count all the way back up to 9 and we stop. So 9 mod 10 is 7 squared. It's just a different way of expressing things. Let's see. I believe 8 times 8 is 64, if I recall correctly. Let me just verify, because it's been a while. I'm a bit rusty. What can I say? 8 times 8. Yep, I was correct. Okay, if you're going to do 8 times 8, which happens to be 64, then it's going to be 4 mod 10. Why is that? Because you're going to go 10, 20, 30, 40, 50, 60, and then you're going to count up again to 4. So 8 squared is 4 mod 10. If you have any questions about this, and remember that your quadratic residue is the 6 or the 4 or whatever number falls into this position, that's your quadratic residue. If you have any questions about this, leave me a comment, leave me a video response, and I'll get back to you. Alright, in the meantime, I hope you guys have a great evening, stay warm, and I'll tell you more in my next video, so stay tuned.